Welcome to our next installment of Chapter 8, Aquatic Biodiversity. 8.4, why are freshwater ecosystems important? Why are freshwater ecosystems important? I wonder why. Going on. Freshwater life zones. So, we've got two different ones right here that we're going to look at. We've got standing bodies of water, we've got flowing bodies of water. Now, the way I remember this one, standing is lentic. I don't know any savvy way of that one, you just got to memorize it. But flowing, what I remember is flowing. There's a hard O in there, flow-owing, right? And then lotic has a hard O in it, low-otic. So low-otic water is flow-owing water, and lentic water is standing water. So these are lakes, ponds, wetlands, rivers, streams, etc. Got it? You feel me? Good, good. Okay, lakes are water-filled depressions, and they're split up into zones, kind of like the oceans were split into zones that we covered in an earlier unit. These are divided into 4 zones. We've got the littoral zone, which is the lake, or sorry, the shoreline of a lake. All right, we call that the littoral zone. The limnetic is the open water area of the lake. Okay, and light can get through the limnetic zone. Okay. Profundal is that area that's above the bottom, underneath the limnetic, and there's no light there. All right, so that is the non-photosynthetic portion of the lake. And then the bottom, when your feet hit the bottom, that is the benthic zone. And if you remember, benthos is the name for bottom-dwelling creatures, so benthic and benthos. What else we got here? All right, so we've got 2 different types of bodies of water. This is a lake, actually. This is not like a Gulf 9 or anything like that. What is it, Gulf 9? What am I talking about? A Gulf Green? Sorry, Gulf Green, not a Gulf 9. This is a body of water. Right? So this is an oligotrophic body of water. This is a eutrophic body of water. So in oligotrophic bodies of water, there are 2 things. They're poorly nourished, obviously, and they're usually newer formed lakes, and they're usually in cold regions. Okay, that the cold prevents substantial growth of algae and grasses in the lake. So those are your crystal clear lakes, the kind we see up north. When you move towards the equator, we have eutrophic, well or overly nourished lakes. These are your older lakes, or these are lakes near the equator that have lots of sunshine, so any algae that's in there tends to grow and grow very well, and they cover the lake. And eventually what will happen is this stuff will grow and die, grow and die, grow and die, and as it happens, all that biodegraded material forms, it accumulates in the bottom of the lake, and that lake slowly, the bottom gets higher and higher and higher until it's ground and there's no more lake. And that happens all the time in Florida. So we see these more near the equator. We see these more up north. If you see an oligotrophic lake in Florida, probably means it's newer. And if you see one of these up north, it probably means that that's an old lake. Okay, streams and rivers. So they're broken down into zones too. How do you transition from the tops of the mountains all the way down into the ocean, if you will, okay? So this would be, this part right here, think of this as the Appalachian Mountains. Because the water from the Appalachian Mountains travels all the way down through Tennessee, through the Carolinas, through Georgia, and eventually down into Florida, us. Now, at the source in the mountains of Tennessee is called the source zone, the headwaters. That's where the snow melt comes from, the ice melt. So springtime, that water is rushing. It's moving very, very quickly. So there is lots and lots of dissolved oxygen because the water is churning, and as that's happening, it's dissolving oxygen from the atmosphere into the water. So the type of fish you would find here are cold water fish that have a high oxygen demand because they're swimming all the time through quickly moving water. So their muscles are constantly moving, so they need lots of oxygen. That would be something like a trout. When you get down into Georgia, you're into the transition zone, right? This is that transition zone. They still move decently quick, and they start to meander towards the bottom, right, at the end of the state. but they don't move as fast. You have, it's lower dissolved oxygen, right, lower, but it's not really, really low. So the rivers are a little bit wider, all right, so starting to get that meandering shape, and it's moving slower than the source. So the fish here need to move quickly, not as quick, so they have a lower oxygen demand, and this is where you find a lot of your bass in that area. Then you move into the floodplain zone, and that is Florida. Very, very flat. It's transitioning out to the ocean. It's the slow-moving rivers start to actually meander and get that side to side. This looks like a top view, bird's eye view of the Econ River. Go to Google Maps and check that out. That's exactly what it looks like. Just as meandering rivers, boom, 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 going back and forth. So very low oxygen levels in these rivers because they're moving slow. There's no churning, and since it's moving slow, plants can grow in there better. So there's more photosynthetic activity going on. So there's more not just plant growth but algal growth. And that algae tends to suck some of the oxygen out of the water as it's dying, being decomposed. Right? The decomposing bacteria consume the oxygen. So you need oxygen, or you need an organism, a fish, that does not require large amounts of oxygen. And that would be your catfish, which does very well in the rivers of Florida. So let's look at the difference here between swamps and marshes. A marsh, a wet grassland. Swamp, a wet forest. Trees, no trees. Okay? They're important, of course, just like I think when we talked about estuaries we discussed, or in mangrove forests. These wetlands act as sponges. They absorb excess water. They absorb excess nutrients. They provide habitat. They protect our coastline. So filter and degrade pollutants, reduce flooding, replenish streams. So these are all pretty self-explanatory. So if you need them, go ahead and pause it because I'm going to go on to the next one. So we like to dam freshwater systems. We use it for recreational activities. Behind the dam, we create, instead of a river, a lake. People come fish, swim, etc. Then we allow the water to move through the dam and generate hydroelectricity. And then we also can then take all that water we've backed up behind the dam to create that lake, and we can shunt it off as irrigation water to different places. All that comes at a cost, though. Dams, diversions, and canals have fragmented 40% of the world's 237 large rivers. If you are south of a river, you're getting less water now if there's a dam there. That means there's less water for any humans who live south of the dam. There's less water for all of the organisms that live south of the dam. And then north of the dam, guess what? There used to be a river. Now there's a lake. So the river ecosystem is destroyed and replaced by a lake ecosystem. Flood control levees and dikes alter and destroy aquatic habitats. We just discussed that. Cities and farmlands add pollutants and excess plant nutrients to streams and rivers. Right, so you back up this water and then you create this lake. That entices industry to build around those lakes because they need access to that fresh water, which means, and same thing with farmers. Now farmers can tap into that excess water north of the lake to irrigate their fields, to water down their cattle while they're grazing. They need fresh water, the cows. And all that water can make sure that the grass is growing thick and plentiful. Well, now you've got all that cow poop, which in a hard rain is going to flow into the river. That's what it is. It is what it is. So pause this if you want to keep looking at it. And that is that one right there. Boom, got another one done.